Good afternoon. We will wait for another 2 to 3 minutes and then we'll start.
Okay, okay.
Sangmesh, you just download once the class starts now, who are attending. Maybe after 20, 30 minutes after you can download, and maybe the end of the program you can download it.
Yeah, I will note down then their
Yeah.
names. Yeah.
Yeah. So shall we start? Uh, Good evening, everyone. So in last class, we discussed. My voice is audible, correct? Okay. Uh,
Audible. Your voice is audible.
in last class, we discussed a little bit about how to start programming. And we also give some kind of overview about the program and what we cover, what we don't cover. And we created a classroom where we were trying to upload all the materials, whatever we covered, the PPT. See, you get all the materials what we uh, used in teaching. So you get here, and you also get the video recording of the session. And so introduction class we done, and introduction to program we didn't. We not completely fully done, but like partly we completed whatever and and all these CS foundation materials like operating system, computer and architecture, like we did around 15 subjects, core subject one should be knowing to get a good job in a CS, means like in software engineering domain. So we listed and we uploaded the materials. Like materials are a little bit like a higher end. So if you are still feeling difficulties, like you can Google and all those things. For the second year onwards, for the students, for them that like we will be covering the concepts, but like for the final year, like 1 year kind of program, we won't be covering all those concepts, but we're just posting the materials and key concepts in one on like operating system. What are the key concepts? Like I will be creating 30 minutes videos of one on concepts actually, but this is not our curriculum usually, but like just refreshing is our curriculum for 1 year kind of program. But like somebody who is joining us from the second year onwards, like we will be covering these foundation courses actually over a period of time. So we'll be covering so that like they will be comfortable there, irrespective whether the engineering college where they're associated taught this subject or not. But like we will be covering as per the industry needs all these subjects for second year onwards students actually. And this is about materials and every sessions like you will be getting. And here I have not added some kind of a quiz or assignment something, but I will be adding quiz and assignments later on. So you should be start working on that. So this is about things, and I just added the people who are all paid the fee for that actually. Like I have invited, so maybe you got an email, so you have to accept that actually. If you accept, then there's something like that you can able to view. So I have invited some people and had to accept actually. So this is how is the course things will be there. And about the today's class, like in last class, like we discussed about how about the Pascal triangle. So what is the Pascal triangle, how to write the program. And I also asked you to try to attempt some kind of program, and I also give the links of visualization, some sites where you can visualize these algorithms, and you can post this content and then see how it executes. But I just wanted to go in further actually. How should we, because a lot of people had some kind of a difficulty saying that like how should I start writing a program, so how should I start building a program logic actually. So what I thought is actually like something like a Pascal triangle. Somebody asked you to write a program for a Pascal triangle. So now so instead of like, if you comfortable directly writing a Pascal triangle, you can write it, or else like you can start thinking something like an artist actually. Like so something like an artist who start with the smaller things and then start building the whole concept. So something like that, like instead of looking for the whole this Pascal triangle, so which has the numbers, like you think about something like a stars actually, like you replace these numbers with a star, like so one star something like. So this and this, there are different actually. It's a Pascal triangle and this is a full triangle with the stars. So see, if you see here actually there is one star, then there is a two star, there is a three 5 star, and there is something that like. So this is one kind of structure, this is one kind of structure. And but the key thing before we proceed about writing an algorithm, we should be knowing, that we discussed in last class. Any algorithm or anything, it will have some kind of a sequence, some kind of a selection, and some kind of a loop. So this is a selection, the if statement or like a condition, something that like you already know. Let me show that actually. So is it visible clearly, correct? Okay, so if you are not visible,
It's
so
visible, visible.
this is a where was it, my cursor? Okay. Okay, so the right hand, let me. Okay. So this side, there is if statement, uh, is this side. We'll discuss later on when we know about operations and logic and like logical operation, relational, all those things like that. But like there is a condition, like something like a condition, whether the person is height is above 5 or lesser than 5 or something like that. Any some kind of a condition. It may be relational or like operational something. So first start execution from here and just check the condition. If the condition is true, one the path it will take. If condition is false, another path it will take. So if condition is true, this path will take. So means like within whatever within the bracket it will be execute, and condition is false, it will execute beyond the bracket. So this is how the is a selection thing. So this is one part of selection, kind of selection. What is called it's a for loop. So it will start with the initialization. So then it will check the condition. If the condition is met, then this, if true, then this will be executed. If condition is false, then it come out of the for loop actually. So this is how the loop will be there. Like there is a for loop, and there is also while loop, and there is also do while loop. These are all different type of loops actually, like for loop, while loop, and it is all depending on which programming language. Like so it may be C, there is a different way of calling for loop, while loop, do while loop, and if it is Python, then there is a different sequence. But I'm not discussing about the which language actually, but I'm thinking about like any programming algorithm. When you are trying to write it actually, you will think of in terms of three key components: sequence, selection, and the loop. Selection means like the conditional kind of things, and there will be loop. And they're more like as the programming language keep enhancing and enhancing, they come up with something like instead of one loop, for loop, there is a while loop, and there is a do and while loop. So we will discuss this in a detail when we are doing a Python program. But like here, just a brief overview. So the loop, for loop I explained, but in while loop, first it will check the condition. So it comes here and checks the condition. If the condition is true, then this is called within the bracket. So within the bracket is called the while block actually, the body of this actually. So the within the bracket, and the thing is, if it is a false, it will come out of the block. But in this case and the previous case for loop, so there is no conditions. Like, so if you are checking the condition, if you are not updating the conditions, like if you say, for example, I'm checking some conditions, like I'm trying to loop up to 10. So means like you are checking the loop is started with the 1. So you maybe initialization can be done outside that. So I have initialized something like here, and then checking for like 10, but you are not updating them, then this condition will becomes infinite actually. So there should be something like a update kind of things. See, if you look the previous thing, the initialization in for loop, the initialization is here itself, updation is here in the statement, like the condition is set. So in this case, so initialization you should be doing outside the while loop, before while loop, and then the condition checking. But within the block you should have an updation. If you are not doing this updation, then this condition will be infinitely correct. No, so somewhere else it has to fall. So somewhere else you should be coming out of the loop. So that is whenever you are trying to think about a loop, so always the loop. Like, so for example, you are trying to do something, you're walking around some park. So there is a start point and there is an end point. So I will do 4 rounds and then come out. So then you will keep on counting. 1 round is done, 2 round is done, 3 round is done. So that is called its operations. Like, so you have to keep track of that. If you are not keeping track of that, how many times you are looping, then that is a issue of like infinite loops. No, so that is one point you should be remembering. So things what you should be remembering actually, there is a loop exist or not in that algorithm. If the loop exists in that algorithm, then what is the starting point? Initialization. How should I start initializing that? And what is the condition on which it should be executing that loop, and when it should be coming out of it? To coming out of it, there should be somewhere else there is updations. because you keep on the tracking. No, so updation is something like a keep on tracking. So the condition is just checking whether it met or not, but it has to be counted. No, so that updation is that actually. So whether it is a for loop, it is while loop, it is a do while loop, but you should be remembering that. So in the do while loop, so what happens actually? First you will be doing it actually, and then you are trying to do condition check. So you are entering here because there is no conditional check. No, so there is no conditional things like so. But initialization has to be done for initially, and updation has to be there here within that block actually. Because if you are not doing updation, then it will be tough. So everywhere, three. Whenever the loop will be there will be initialization, there will be condition, there is updation, and wherever there is a selection, then the condition has to be there. So when what condition this selection should be true, and I should be executing true kind of statements. Like for example, if you are going for a bus, like so if you are trying to catch a train from Yeshwanthpur actually, and you need to know that okay, if I have to like 7 o'clock is there, like at what time you should be deciding. So I'll assume that like 6 o'clock if you are leaving, then I should be I can't take a taxi or like a bus and go, because bus will take so much time. If I have to go, it's like so depending on that time and something like no, so you should be taking decisions. Selections always will be there. Like so, if the time is 1 hour, then what kind of transport I should be using? Time is 2 hours, then what kind of transport I should be using? So if time is like 30 minutes, then how should it's like so everywhere like so you always thinks in terms of there will be always selection, there will be always sequence, there will always loop. So this is the key thing while thinking about like so there is while statement, and the other things is actually like somewhere else, like if you wanted to certain conditions will come, like that has to be break actually. Like so you there is something, two more statements are there, break and continue. So what they will do is actually okay, operations I'm trying to do actually, like but there may be some conditions, like for example divide by 0 comes into, or like some other conditions, like then you have to breaking that actually, means like you are coming out of it actually. So or then this you can use in two ways actually. Like one way is actually like you can keep updating and then checking the expression, or else like you keep infinite loop and then you have a condition. With that condition, if that condition is met, it will break. So only that condition is met, then so that is also a way you can use it using the break actually. But the better thing is this is what like so break and continue is always difficult to debug things. So how it is happening, because break and continue is difficult to know. So continue is actually like if you have executed the statements, like whenever this condition is true, you start executing this statement, and this statement, because there is no break actually, because condition is not met. Okay, the break, there's no break. So you are executing, and after that, like instead of executing this, like there is a condition is there, and if the condition is met, so you will, instead of executing these two, you continue again from this point actually. So mentally you can skip this execution. There may be some possibility cases actually you have to skip for something. So if it is a odd and even number, like if you are trying to do odd number and even number, and if it is a odd number, so you need to skip this, then you have to check whether its number is odd, then continue. If the number is even, then you should be executing. So after executing this whole loop, no, automatically it will start executing till that condition is met. So there is some two more statements are break and continue, but that they are not that much important. But like if you look actually only three sequence, loop and something. No, we know what are the key components of the programming. Now we have this problem statement. What is the problem statement? We have to write a Pascal triangle. So instead of attempting file in first go Pascal triangle, you should start deciphering in a smaller kind of things. So any questions so far, like any questions here in do while loop, for loop? So any questions? I think you already know these things, and you also know something like inner loop and outer loop. So this is outer loop, and there is an inner loop. Like so, these are like basic kind of concepts, and maybe second year students who are may not know this. Like we will cover that, but for others, like it will be simple. No, there is a for loop, there is a break, and there is a inner and outer loop. Like you can have any number of nested loops. Like you can have multiple number of loops actually. So how many times this will be executing? This will be executing till this count lesser than less, it's like up to 50 times. If it is count is initialized to 0. And how many times this will be executing, this code will be executing. So this will be executing every time if it is entered up to 25 times. But this program block is entered 50 times. No, so to 50 into 25 times. So that is how it will be calculating. This code will be executing only 50 times, but this code will be executing 20 times whenever you enter into this back. But this block you are entering 50 times. So it's like 25 into 50 times. That those many times it will be. So that logic you should be knowing. So how many times that inner loop will execute, how many times outer loop will execute, that you should be remember. It's like you should know how to decipher, because that if you know that logic, then only you can write the algorithms actually. So I think these are the basic key concepts. So if any questions, let me know. Like then I will go how to write a program. So any questions so far? So now, so now I said about like whenever we are trying to write a Pascal triangle. So instead of like just directly attempting the Pascal triangle, what is the complexity in the Pascal triangle? So see, there is a one complexity actually first finding out how many elements per row. So for example, if I am to write a Pascal triangle for 5 lines actually, like line 1, line 2, line 3, line 4, line 6 lines actually. So if you are trying, then how many elements are in the line 1? So number of elements are there in line 1 is 1. Number of elements are there in line 2 is 2. Number of elements are there in line 3. So this is how. So it's like, okay, that this is much more easier. But are all these elements are same? No, it is a difficult. So all elements, there is some kind of a logic I should be finding out. Instead of trying to find out the logic about like how this number is derived. So you first think about actually all these are like a simple stars. So something like look about something like a stars and start writing program for those kind of stars. See something similar to how the artist does, like how the artist does actually, like they won't be starting. They're written some circles and then circle and then they written something and then draw in between. So you start building step by step by step by filling. So that is how you should be building. You should not start suddenly. If you are comfortable, you can start in one go write a Pascal triangle. But when you are building a logic and algorithm, when you are building that mindset actually how to write a program, so you should be starting something like this actually. So how should I start for this? So first thing is actually, okay, this is all the Pascal triangle. I represent instead of numbers, I represent in terms of stars actually. So what I did actually, I instead of converted this problem statement into a simpler problem statement with stars actually. So what happens actually now after that I started finding out is there any relationship actually. So what is the relationship? Line 1 has 1 star, line 2 has 2 star, line 3 has 3 stars. Oh, it's fine actually, like it is number systems, correct? 1 to 5. So if say somebody said like print a Pascal triangle with the stars for 10 lines, like okay, then I can write 1 to 10. So what is that actually? 1 2 3 4 5 6. So you can think like this also. See, instead of like completely writing, so we'll say start statement 1, print star 1. So statement 2, so this is all sequence, correct? So sequence statement 2 is like print star and another star actually, 2 stars actually, I need 2 stars. And statement 3 is star print 1 2 3. So this what is this is like at least you should be able to think. No, so this is how it. No, whenever I have to print 1 star means like I have to call printf statement 1 times. No, so whatever are like printf statement once, or like in the Python it is a print, or in some language it is a printf, whatever it may be. I'm just calling it as a print, maybe print or printf, whatever, depending on the programming language. But whenever if I have to print 1 star, then I have to call print once, correct? So if I have to print 2 stars, I can call two times print actually. But instead of doing that, like if you say 2 stars, then it will be difficult. No, programmatically. So what happens actually? This print star 1, I may call number of times depending on the which line it is there. So then first way is actually do in a manual way. The second is actually you figured out actually, okay, I need to find out some kind of a loop or repetitions. So instead of doing that, so what kind of loop actually? So you figured out actually something that like I will be using something like a for loop. So I'm not looking for this looping for the outer, but whenever the statement is there, like if statement line number 1, so then I will be printing. I have one loop which will print 1 times. if the statement 2, then I have a loop which will print for 2 times, because I'm saying number 2, line number 2 means like 2, if I pass, then it will print 2 times. And if statement 3, then, so I figured out actually there is an inner loop is there. So I figured out there is an inner loop. So that inner loop will print how many stars for, depending on what line of the code. So if you are trying to print on the 5th line, then that loop will execute 5 times. So what is that loop consist of? Just print star. So that is how you should be able to. Then you figured out one code. So you figured out one loop. But the thing is like, so this is for one, but how many times I should be doing, how many lines I should be doing, then there is an outer loop. So this outer loop will say that like how many lines are there. Somebody will say that like I wanted to print for 5 rows, or I may say that like I wanted to print for 10 rows. So then this outer loop says how many rows actually. So it will start counting line 1 or row 1 till 10. So then, okay, then what happens actually, I got row 1. So I found out the row 1, and okay, so it should print for 1. Okay, then I should have an inner loop which will execute for that actually. How the logic will be, so the starting point will be 1, but ending point will be what is the value of I. So because, so in line 1, the value of I is 1, line 2, value of I is 2, line 3, value of I is 3. So because the I is the one which will count the row number or line number, correct? So now the inner loop will start repetition how many times depending on the line number. So means like condition should be, so it should be start from the j is equal to 1 up to the line number. So this is what you figured out. And finally, what you should be printing is a print log. So now what is the logic I'm trying to do? I'm just using two loops actually, inner loop or outer loop. So I figured out what is the inner loop, and I figured out what is the outer loop. So outer loop is dependent and the inner loop is dependent. So now what happened actually, like we are able to figure out and we are able to write a program to write these stars. So now I'm able to write the program to print this actually. Like, so I am able to build this. So you can test that actually. So I have built something like this. Like, so what is that actually? So now then what happens actually? Who will give that number of rows? So means like there is something like an input. No, so you should be, user will give that. Like, so now I added something that okay, user will give the input. So I should be reading that input from that. No, so I will be reading from the user saying that like enter the number of rows, and I will read that, and then I have written the logic actually. So this is how. So okay, is it end? No. So this is a starting point. I just, instead of like writing a Pascal triangle, I did something like a Pascal triangle of a stars, not the numbers actually. So that doesn't all the actual things. So now what else actually? If you still wanted to refresh or like still have a difficulty in that understanding, so how should you do? So I already told you that like where is the and put the code and start executing and running and seeing it actually. This is a place where you can post your code and start executing it actually. So you can just, so this is like a smaller, like initially like you need to do a lot more times like this actually, but you are it's like you're sampling it actually. So still if you're not able to understand and read this, so this is what you do. And then next thing, so I told actually how to execute and how should see. And I also explained you that like how exactly the code tracing happens. In the last class I told actually. So here all the so actually here number of rows, but in this case like it is the column and the value will keep updating here. So actually like the way I explained is actually one direction. So this is the number of rows. So here keep on updating, and here number of all variables will be there, whatever the variables. Like, so if there is a I is variable, J is variable, row is variable, so means like first iteration means like first line. So what is the value of I something? But in the visualization the site actually, the here they have done something different way. So what they have done is actually they have figured out actually what is the stack, what is the heap. I explained this in the first class also. So what they are trying to do is actually, instead of doing everything like that way, what they are saying is actually this is a stack, how the stack looks like. and and variables will be, all these variables will be here, and name, and here the value will be there, like so this is I, J, or something row, whatever the value keep on updating. So and there heap looks like. So they say that like, so whenever you do heap, so this is if you want to debug this, not able to figure out this way. So you try the way I said actually. So here all the variable names you should be as per column. You should be putting all in column, and here number of like iteration first, what is the value of this variable, iteration two, what is the value of, so that is also you can trace, like you can use this visualization tools. So you should be doing this to understand the logic actually, like so. Now once you are comfortable with the, the logic, okay, now I'm comfortable with the logic of writing the stars. Okay, can I do little bit like increase, start building? So okay, can I introduce a some kind of a numbers, like I don't want the Pascal triangles, but can I do some kind of a sequential number? See, what is this actually? This is one line, one number, two numbers, three line, three, same thing. But instead of stars, I just replaced with something like numbers actually. This is called half pyramid of numbers actually. This is a half pyramid. Can I write something like that? Okay. So only thing the difference is actually, instead of stars, then there will be some numbers, like where exactly I should be changing. So that the changing location, if you look the program, what was this program here, the print star. So okay, there is a star, but instead of star, I should be writing some numbers actually. What is that actually? This is where I'll be changing. What is this number actually? If it is, let's see, first thing is like there is outer loop. There is no change in outer loop, correct? So I'm not trying to do anything because I'm not changing anything. Outer loop will be always same. So now what is changing actually, like whenever you entered into the inner loop, so you should be printing, instead of a star, you should be printing some number. What is that number? That number is actually from from start point is 1, but it keep on increasing. How many elements like stars has to be printed? No, so here like how many numbers has to be, elements has to be printed. So now start point is 1, but it should execute till the number 2. No, so line number dead. So you should keep on incrementing. So what I'm saying, j is equal to 1 and j is less than I. So j plus plus. This is all done. But only thing is like instead of star, I'm trying to just printing. So what happens actually, like whatever the way I'm tracking the j, that just I'm printing it actually. I'm just, so nothing nothing that like, so just instead of star, I'm just printing the j, because what happens, j initially it will be like in line 1. So this loop will execute only one times, and j is 1 and it will print 1. If line 2, this loop will execute 2 times and j is initially 1, so it will print 1, and j is incremented, and the second time it will print 2. So this, so then line 3, so again j starts 1 and this loop executes 3 times, so it will print 1 and then j plus plus, then print 2, then j plus plus. So this is how it will happen. So that, okay, no, okay, fine. So I first it was a Pascal triangle, then I simplified into the simple kind of a triangle with the stars, and now I did something like a a number with that. So if you wanted to do something more, then you try how to write a reverse number. Like, so instead of like printing 1, so 1 2, so 2 1, so 3 2 1. So then what should you do? So if that is the logic, if you are trying to do, so you are trying to do something like start initializing point is from 1 till you are going for the upper number. So if I'm trying to do something like a 2 1 or 3 2 1 or 4 3 1, it's like I should be initializing with higher number and coming till towards 1, and instead of positive I should be doing negative. So this you should able to start thinking, okay, this is a problem, this is a problem. Instead of like doing the half pyramid of numbers, if I do okay half pyramid of numbers but the reverse of the number, so how should I do? How should I change this logic actually? So how should, say this is the code, okay, this is the code, you should take it, and then you start writing the other way around actually. Like then you start playing around that. That is how you should build your logic. So suddenly like you cannot by hat it actually. So okay, then I got this. So this I am trying to change. How should I change? Okay, so if I say start with this number, like so if the, if the line number 1, you should start with 1. If line number is 2, you should start with 2, because 2 and 1 reverse way means, if line number 3, then you should start with 3 and up to 1. So it means like j initialization not the 1, but j initialization is about this number, like 1 2 3 4 something like. So j is initialized, and but here instead of increment, that you should be able to think. So then, okay, now we have done with that, and you did a reverse. You can also do something that, okay, other way around. So if instead of printing first way from one line one, but something that like if you have to print 5 rows, first you write the information of the row 5th, then row 4, row 3. Then what I'm trying to do? This the row number is inner loop or outer loop. So this is outer loop actually. So this program and this program and this program, what I am trying to change is actually outer loop, not the inner loop. That intuition you should come actually, because see what is happening actually, like in this loop, in this program, I am trying to start I is equal to 1, because I is equal to 1 and I keep on increasing. But in this program, I am saying I is equal to 5 and then keep on reducing it actually. So that is what, like, so this whole logic you are trying to do in a reverse way. So then if this is reverse, then how should I do this other way around? Like, so is there then anything to be changed or not? No, because this is 5. So this loop, first loop will be executing up to 5. So it will start 1 to 5. That's fine. So if you have to reverse this other way around, so I'm not touching the outer loop, I'm just touching the inner loop. So that kind of intuition you should start building. So if I try to do reverse, can I need to touch the outer loop or just need to touch the inner loop? So if I do this kind of a reverse, can I touch the outer loop or inner loop? So this is how we start. So this is an inverted half pyramid numbers. No, so the inverted half pyramid numbers. So if somebody asks actually inverted half pyramid numbers, okay, so you build the pyramid. So Pascal triangle to star, then star to number, then number to inverted. So then, okay, can I do something like a B, C, D? So now what is that actually? So can I write like, so these are the 2 assignments you can try, attempt actually, because I have explained this. So you try with the reverse of that, and you try with these 2 actually. I just explained. So what is the change here? So the initial point is A here, initial point is BB. This is something like a star, but it is not completely star. But what is happening is actually every time, every row, the number is constant across the whole line. All elements on that row is same, but that is incrementing. So that is incrementing. So how should I start that one? So you start writing that actually. So logic for this, and this is one. So then what happens actually now? Okay, you are comfortable with whatever the way you are trying to build. So then you come to the something like a full triangle, I said. No, so the full triangle. So if I have to do full triangle, then what is the logic here? Okay, this is not a Pascal triangle. See, there is the difference between the Pascal triangle and full triangle. No, in Pascal triangle, 1 row, 1 line, 2 something. This is a full triangle. Even the Pascal star triangle is different, correct? This is a full triangle of stars, like 1 row, 1 line, 1 star, 2 row, third star. So and then 5 star, then something. So what is the relationship? Okay, so now you should start understanding what is that logic. So you think that like this is 1, then third, then 5, then 7, then 9. Then what is the next number? This is what maybe aptitude, somebody is say an aptitude is to say, no, find out the next sequence number, correct? So there is 1, 3, 5, 7, 9. Then what is the next number? So this is what like logical. So they would have asked in aptitude test actually what is the next number. So something like that actually. So what is this actually? This is a odd numbers, correct? This is something like a odd numbers, like even number is skipped actually. So one way is you can find out the odd numbers, or else like you can think how should you write a odd number? So you will be skipping. So you will be skipping, like you will be incrementing. See, so J, if instead of incrementing, so initially start with 1. How to generate a odd number? J you will be incrementing, incrementing by J plus 2. So if you do J plus 2, then you will be getting odd number. So this is one way. Or another way, if actually like how should I get a odd number? Like something that like 1, then 3, then 5. How should I get an odd number? So there is another ways actually, like so one number, like so something that like this I is the number element. If I multiply by 2 and if I do minus 1, so if I is initially is 1 and I is initially is 2, then I is 3. This is third element. No. So now if I say then if I is 1, then I is equal to 2, because that is how the row numbers. No, all I is equal to 3, but I should be getting here J is equal to 1, J is equal to 3, and J is equal to 5 I should be getting. So now if I put the value here, so I is equal to 1, if I put 1 into 2 minus 1 is 1, that is correct. So 1 into, this is 2 into 2, 4 minus 1, 3. This is correct. So 3 into 2, 6 minus 1, 5. It is correct. So then I built it. So you can build, you can come up your own way. So you can do J plus or something. So can you able to figure out that the core about this programming in this one actually, if you have to print this full triangle with star, the logic is actually finding out how should I find out how many number of elements like stars are there. So the see upper outer for loop is same, but only thing I have changed is this the calculation of the condition. So this will be checking the condition. Remaining all is same. So if you look this triangle, where is this triangle? This triangle. So j less than 1. So the same. And this triangle, where was that? This triangle. This is what the logic. How I got this logic? So you tried this way. So you find out the logic. No, so you find out this logic. How you do? How you do? You try just like aptitude sequence. No, 1 number, 3 number. Then how should find out? You find out an equation for that calculating instead of finding, because manually, mentally you have done that, but you put into some kind of equation. Because when we write a program, then you have to put that whatever the way you are calculating, that you have to put into some kind of equations. So you should think about that and write that equations. So when you try to write that equation, then you are able to do that. So now what all the things I did the full triangle, I did the Pascal triangle with the star, I did inverted half pyramid number of, then like half pyramid with the alphabet. So so it's like, no, I not only Pascal triangle, it's like, no, any variations is possible. Like I'm able to figure it and I'm able to write. So then, okay, everything is done. Can I write now something like a Pascal triangle? So this is another assignment. So like I told you that, like, how should we go about the Pascal triangle? What is the relationship between this and this? So starts with always 1, ends at always 1. Correct. So, but how this calculation? So then, okay, this is 1 and this is 1, this is 1. But when I start with, okay, 1, then the second number is always the in previous row, you will be this number and this number, whatever you are trying to add. Like, so this number and this number or next number will trying to add, and you are getting this. So what is this? This is 1 only. There is no next number. So I got it. So first one is first. Second one, actually, this is 1 number. There is no next number. I will write here. So this is 1, this number, there is no previous number. Then I'm just adding this guy got 1. So this is 1, there is this number, there is no previous number, like 0 and something, I'm adding here. This number and this number, I'm adding here something. So this number, and there is 0, something, that this is how. So logic you got. So whatever the previous, so then you write this logic actually. You start writing this logic and then you try it out. So I explained in the last class, but you start writing that logic. So if you are not able to do, then you come back to me. But you at least like, so you able to figure out, at least see if you are able to write these things, then you should be able to write this also. And there is something like a flight triangle. What is that flight triangle? So flight triangle is actually something that, like, you will be starting 1, whatever the number, then instead of writing again 1 and 2, so you will be starting with 2 and 3. So again starting 1, so you will keep continuing that number. So 3, 4, 5, 6, same thing. 1 line 1 number, 2 line 2 number, 3 line 3 number, 4 line 4 number. So outer for loop is always same. So because that is fine. But in inner for loop, that number is the loop number of elements is same, but the value what you are trying to print is different. So instead of like, so what is that continuation? So how should you do that? This is very much simple. Only one line you should be changing. So you should be able to think actually. So instead of this J, what you are trying to do here. So this number is continuous number. So something that, like, you will be somewhere else you should be saying that, like, count is equal to 1 or like sequence is equal to 1, and that sequence you should be keep printing here and keep updating here. So what happens actually, this is whatever it may be. So it keep on printing that, like flight triangle can be easily. So this is start with 1, 2, 3. So then, so like that you should start thinking and then doing it. But if you're still not able to figure out, there is always there. Like you write any kind of junk or logic or anything logic, you just execute it and see it, like whether it is working, what I thought about. So how should you use? Okay, you write an algorithm and you thought like this is how it will be execute. But if it is not executing that way, you start executing and seeing it actually visually, you can see. So I hope is it clear? Any questions? How should you approach building a logic? Any problem statement, like start thinking. So if any concern, any questions, let me know.
No question from my side.
So, this is how you should start. So I just decided I shared you there are like set of problems, like 100 problems. So these are all problems from the top companies asked actually. So something like see this Pascal triangle actually is asked in Google and Amazon. So writing that. So there is a different variations like so he how should write like so instead of writing he's saying that like you have to put into some kind of a list actually and then return that. So something that all these questions are big like if you still finding a difficult kind of these things, so you go with something like these kind of basic kind of questions. So then you solve these kind of basic questions like array stack and queue and something like I am giving this actually. You try this actually. And how should we you go like you go one by one and like at least simplify that problem and then you start writing it. So the way I said no this artist does like so they will just write a circle and then keep on building and something like that. Like so that is a way you should also start. So you should directly jumping into Pascal triangle, you start this becomes comfortable if you know already the writing these stars actually. This will become comfortable if you know how to write where was that actually. Was here. So if you are able to do this half triangle, so if you are able to write for program for this, then both will be. This is also easy. This is also easy. Step you should start building it. And any questions so far? So now maybe you maybe understand maybe okay now you understood actually okay I need to write an algorithm I should write a program and something. But the question may comes actually like if I have to write and practice what kind of key algorithms or key concepts we should be looking for. So these are the something like a key like mathematics bit logic there is a like there's a link I will give. So these are the things you should be start building it actually like uh, bit magic recursion array search sort or something. And but maybe you people may be thinking that like why should I write this kind of program. So you may be thinking that like oh, why I should write this kind of programs, what is the useful of writing like why only these algorithms like something. And then I will say actually how exactly it is used in a real world. So first is actually you should learn the algorithm and also know like how this is applicable or used in a real world. Like so, take in case of, about inventory management. We maybe heard about inventory management. Inventory management is actually how like bookkeeping. Like there is one store is there. Like how many different goods are there when the goods come and when the goods is sold and how many left out and all those things. Like so, it is a 5 kind of steps actually like inventory addition, inventory subtraction, something like that. Like so I'm just giving a real life kind of examples like why these algorithms and how it is used. So take these conditions I said. I'm trying to say that like how the searching and sorting kind of algorithm is used in a some kind of a inventory management. So how what are the things actually like so if you look the objective of inventory management objective is actually preventing dead stocks means like reducing like we checking actually is there any dead stocks or not or optimizing the storage cost. So many things like first what is that preventing dead stock means what is exactly that preventing dead stock means like so assume that like I have purchased 10 different products, how many products are getting sold and how many products are keep lying like that only. Dead stock is actually like keep lying, nobody is buying it actually. So what is that? How should I know that like nobody is buying it actually? So how should we track whether some product is not at all purchased at all? So how should we like whenever the product is added? So something that like product XYZW. So this product whenever you add it, there is something like a date. So add date means like this product is I purchased or like inventory I purchased or added in this date and when it is sold. So for example, if the add date and there is a sold date will be there. This is how it bookkeeping. No? So there is an add and there is a sold. So then how we can calculate how many number of days this stock exists in my place. Like for example, if my something like I purchase a soap, like different kind of soaps, and I'm trying to say something X is from some Himalaya, Y is from some other like nearby some soap, and Live Boy is another soap, Santur is another soap, something like different soaps. So all 10 soaps I purchased. So are like one on one. Assume that like one on one only. So one item. So one on soap I purchased. But something X is like Santur soap. So it took 6 days to sell. So why something that like Himalaya Live Boy, the 3 days it will take to sell. So something like another one is Himalaya, it takes 8 days. So something another one is something that like some XYZ, assume that. So that is 6 days it takes. So then how should we know which is the best one? So what is that actually? This is first is the add date, then the sold date, and then you are trying to find out what is the logic you are using, the difference between the date, number of days, correct? So this you have calculated. This is there, but this you are calculated. And then what you are trying to do? So which is the dead stock means like which takes more number of days to correct. So which takes more number of days to sell. So that is called something like a dead stock or like least frequently sold. So that is what I should be calculating, correct? So then what is that I'm trying to do? This is the number. Then what I'm trying to do? I'm trying to do some kind of a sorting this, correct? I'm trying to sorting this number, correct? So I'm sorting these numbers. So now you were saying that like how the search is used. So okay, I understood actually sorting is used. So how the search is used? For example, instead of one items, there is something like a 10 items are there. So assume 10 items are there, and somebody is like, how is the system will be there? Like for example, system is something like this. So X has 10 items, Y has 10 items. Then date I got it actually like this is a one date. So this is a inventory add date, and there is a sold date. So now I'm trying to say entire stock sold. So then there is whenever the there is a billing happens, what happens actually? So well, whenever billing happens, okay, this person sold X, purchased X actually, then I sold one X. So then what I will be doing? I cannot decrement Y. I have to decrement only X actually. So you will be searching, no? You will be searching that element. You will be searching that element and only decrementing that element. No, so this is assume that this is a count. This is a count, correct? So then what was the left out count? Like left out count is actually I will be one is sold, so I will be decreasing this. So what is that actually? You will be searching that element, correct? So this is a list of all items, correct? This is a list of items. So you'll be searching that list. Then only you will be decrementing. Like if you are able to not, so there is how you will be using search. So you will be using search. Then I told you actually how you will be using search. Sorting. So what kind of searching algorithm? What kind of sorting algorithm? That is what you are trying to learn. No? So if you are writing a good searching algorithm, sorting algorithm, this is in real application. This is where you will be writing those sorting and searching kind of algorithms. So I hope I explained actually like how the searching and sorting in real world. So this is okay. Oh, this is all about preventing dead stocks. So it's like I'm trying to find out which stocks takes more time, which product takes less time. So that is how I should be doing. No, so that I should have that kind of thing. Initially, if you are not doing this programmatically, then how you will be doing? Somebody has to be there and somebody has to keep track of that actually. Like so, if I assume that like somebody not using a software, so what he will be doing? He has to have some kind of a chart, correct? Chart with all this name of this products, correct? The name of this product, and then he will be keep tracking it. So in add date is there and the sold date will be there and number of days. Like so, keep on like what happened? Like so many person has to go and track and check and then update. It's like so many people it's like one or two people has to be there maintaining this a whole inventory and which is the dead stock, which is the fast moving stock, which is something that like so much like what we are trying to do. We are trying to reduce like so something a routine kind of activities using the software. We are trying to reduce that and optimizing it. Like so, what happens actually? The software guy, the shopkeeper, just has to use this tool and understand. So apart from that, like I will explain how the data analytics comes on this actually, all those like graphs and something. So to make him that like, intelligent decision. So just like these are the numbers, no. So what the data science and AI comes, this number he will highlight. So in some kind of a graphs and charts and saying that like so then he will see, oh okay, see for there is no point in selling more. See by the time I sell one jet, I would have sold how many? Two, more than two, up to three, 2 point something. So three Ys, correct? So why should I waste actually? Like even if I'm getting 15 rupees per this one, But here I'm getting 10 rupees also, but like I'm getting 3 times, no, 30 rupees there. So that logic, that different graphs, different charts, like price and all those things done in the analytics way, in the with using the graph and data science. So what is the data science does actually? Whatever the information there, that will beautify and help you to take a decision. But at least like so, that is like I said, I just wanted to show that like how your logic will be used and how analytics will be used and what is the useful of this software. So because if you don't know the usefulness of the softwares, then you know, like see, maybe saying that like I should be rating, because what you are trying to do is actually you are trying to reduce the number, I mean, resource cost. Like so, the things happen that when the software start entering and developing a lot of softwares, a lot of this kind of tools, automation of these tools. So you are reducing number of resources needed, manual resources needed. So that is how the things are happening. So they are reducing these manual resources whom they have to keep every month some salary. Instead of giving that, they are buying the softwares and generating all these insights. So that is how the things are happening. It's like this softwares or data science and AI trying to optimize, like automate a lot of things and give a lot of insights to the owner and reducing the resources. But it is increasing more jobs to the people who are writing the softwares. But you should be knowing, but like you should be capable of writing those kind of softwares. Like say any real world kind of problem statement, you should be able to decipher and you should be able to some kind of automate. Like so, I'm trying to say that like, how to find out like a dead stocks actually, you know, programmatically. So what is finally, if you decipher and into step by step, what we got is actually some kind of a structure, like how should we keep track of that information and some kind of addition, so difference between that, and then some kind of a searching algorithm and some kind of a sorting kind of algorithm. So if you know what searching, different searching algorithm, you apply the searching algorithm. If you know what is sorting algorithm, you apply that respect to sorting algorithm. So fine. So finally, what he is to know? Okay, if you look actually, like if only two stocks he have products he has to keep, so he may be keeping only X and Y, because there are 3 and 4 days it will take to sell. But if you wanted to keep three products, then he will be keeping X, Y, and W, because that's all sorted. After sorting, that is much more easier to know. I wanted to remove only one or something. Like when you sorted things, like you know that like okay, top 5 I should keep, or bottom 3 I should keep. All this is pretty much easy to take a decision. But that is all happens when you apply the sorting algorithm and sort the things and put it in a proper shape. Correct. So that is what the programmers uh, objectives, like they will be doing that actually. So any questions here? Okay. So next thing actually, like okay, I'll solve one more thing. So for example, that is not only this. Okay, this doesn't solve actually. Like how should I take a decision? Because even though some product takes more time to sell, but if the profit margin is more, so and it takes more space actually. Like for example, soaps takes small space, but something like a washing machine or like something vacuum cleaner takes more space. Correct. But vacuum cleaner takes more space and soaps takes lesser space, but both gives a profit margin same, because profit margin is what necessary. No, for example, if I get purchase the product with extra profit margin, I think you already know. No, so if I got a product with X price, so something like 10 rupees, and I'm selling it 15 rupees, that my margin is 5 rupees. So and if this product is taking 100 square inch actually, and our margin is 5, and another product which is taking 200 inches, but margin is something like 8. So which is the like if I have to calculate which product I should be, like both are selling is like 3 days only, I can sell within 3 days both product. There is no number of days it will take to sell is same, but the difference is actually, the difference is, so it takes 100 square inch and this takes 200 square inch, but profit margin is 5 here, profit margin is means like I can keep two product here, I can keep two product here instead of one product. So if I sell two products, then I will got 10, here I got 8. So all those calculations. No, so if that is called that concept is called optimizing storage cost. So how should you optimize your storage cost? So I have this, because every Nobody has something like infinite storage space, correct? If I'm doing a small shop of like 10 by 10, there's a fixed size. If I'm saying that like if I have a small almara and which is space is fixed, so always there is a within that only I should be selling. So how should I find out? So then how should I keep track of that, and how should I take a decision out of it? So how should I keep track? Same thing, like take a table, the product name, the items sold, how many items are the sold in that 1 month. Assume that like per month you are trying to calculate. So I'm not said in and out, but per month you are trying to calculate. So how many items sold per month is this, and margin on product means like how much profit margin I have that one, and how much space it will take. So each item, how much space it will take. So 100 square inch. So what I'm trying to do, I'm trying to find out what is the total margin. How should I calculate this? This is simple, correct? So this number of items sold, this one. So this logic you should be able to think. So total margin I got, then what is the total space, how many products, and what is the space. So 2000 is the space. Then with that, what I am trying to do, okay, I got a total margin, I got total space, then price per space. What is the price per space? So this price per is 0.1. So for Y, the 0.15. For Z, it is 0.12. For W, it is 0.087. So which is the lowest, like which is the highest I am looking for? No, I need to get more profit. So highest is the Y. So I'm keeping Y more, then Z, and then X, then W. So then what I'm trying to do? So what is this actually? So this is also possible by sorting the algorithm. So what is that like? You will be sorting that thing. So this will be sorting the number. So which is the highest and lowest. So it's like this all is like sorting, searching, adding, this all these logics. Like so, first is actually first know those basic concepts, and then you should be knowing that like how exactly you should be applying in real world life. So in real world applications. So I hope understood it actually. And all these algorithms, like even though it looks like actually a dummy kind of algorithm, but like in real life they will add a lot of values. So instead of like say unsorted, like so this is 4, you can sort easily, you can remember. But if it is 1000, if it is 20,000, it is 30,000, it's very difficult. You have to sort, then only you can get top 5, top 10, top something like that. So without sorting, you see, manually I can do it just it is a 4. All these calculation I can do manually because it is just 4. If it is 1000, 1 lakh, then it is very difficult. All you have to do programmatically. So manually it is very difficult. Like so, if the scale is increases, like manually is not possible. So all you have to do is a program. So to programmatically, you should know that like what is the input, what is the output, how the relationship between these two. So I said no, total margin. What is the relationship between this and this? Total margin relationship is actually number of items into the margin. So that is what you get there. So that logic you should be able to do. How should I update this value? How should I update this value? How should I update this value? And after that, what I should be doing? So means like this is how the like step by step you should start. Okay, I'm trying to find out like optimized storage cost. Then first thing I should be able to find out this kind of structure. How should I capture those relevant information? What all the items necessary for? What are the information necessary for them? So product name, this is. Then what kind of data structure I should be putting into that, storing that and retrieving that. So they all boil down into some kind of a data structure, some kind of algorithm, and some kind of a step-by-step approach. So you cannot directly think like so. First step, okay, then step relationship between, then relation like this is a calculation. After that, then the sorting. Then after sorting, then again rearranging something. So if you wanted to rearrange this actually, then you will be rearranging or like just printing them in the proper order. So you should be knowing that like okay, if I have to build a report of that or graph or that, like what is next step? After that, after this, next step is sorting, and after that like actually printing top 2 or top 3. So then from the sorted list you should be printing that with the name. So then the whole objective is solved. So break into that problem statement to small. You start thinking that like it is very difficult initially, but I said no, the way the artist right now, so piece by piece you start adding and then become a big, like you build some kind of a solution. So that is how you should be practicing. And the how you will be practicing that. So you I will also explain that, but any questions so far?
Yeah, clear everything.
Okay, so now the another point here, no, whenever you are trying to explain this or like writing this, actually the another like algorithm I about told, but another thing is actually like what kind of data structures we should be storing into. So I said about this one because we should be storing into somewhere else, no, so data structure. So then you start, okay, there is something like a array is there is something like a structure is there is something like a dictionary is there. That will cover actually whenever I'm covering Python. But briefly, array already you know. So already is like array is the same kind of elements, no, same kind of element like 7, 8, like all this like. So what is that actually? Like if you look here, all this is all same kind of elements, correct? So all these items, all sold is all some kind of a same kind of numbers. What is this kind of number called? Integers. So all these are integers, and only this is a float. So much like what you should be knowing actually, what kind of primitive data types are there, well-defined data types are there. What are those? Integer is there, float is there, character is there. You should be knowing that. First is that. The second thing is actually whether I should be putting all this information in terms of in an array or in terms of in a structure or in terms of a dictionary. So you should be deciding that. So we'll just like whenever you know what is array, structure, or dictionary. Usually these kind of things you should be putting in a dictionary. Dictionary is in Python actually. So I will explain. So dictionary means like this all these elements, whatever these elements are there, they have a name. So you can keep this name and different elements, no, different types. You can keep that actually. Like so, you can even structure also something like that. Like so, one is the name, second is the number of elements sold, and the third is the salary. So you can put into some kind of a structure like this is name is one, item sold is another one element, another one element, another one element. These three elements is given, but these three elements are calculated. So that also have to have somewhere else has to have a storage space, correct? So total margin source or something like so. Then you have to decide actually which kind of structure. So if you're don't think about like optimal structure something, but like first at least you are able to write a code. So simple code using a simple data structure which you are comfortable. You should objective has to be resolved, and then think about actually whether the structure is good, array is good, or a dictionary is good. So that is how you should start thinking it. But before that, so you should be knowing about what is meant by array, what is meant by structure, what is a dictionary. So if you still confused, like so, first I said no, second year onwards, guys, I will teach, but other people, I have already added some kind of a materials, like so you can go through that. So there is be a lot of materials are there which will cover these basic things, and this is one algorithm book is a very good book is actually, so you can look into that. So but if you have still questions, let me know. So the structure is point like so is addressed, and these problem statements like whatever I said, like no, only inventory management I should be doing that. No, these are all generic one. So for example, if you have an Alamara and if you wanted to find out how should we utilize that space effectively. So means like maybe assume that like one wife has something like 1000 series. So instead of randomly putting it actually, which in a year, which series he will pick up most frequently, you find out like which series should be frequent, like same thing, no? So if you look this diagram, so this is different number of series, and this is instead of number which day something that like it will be something like day 1 to day 365, and which day which series counts. So which series how many times she picked up actually. So then which are more frequent, like most number of times she use that series. So you will be putting those things. Oh, again this is sorting, correct? Sorting thing, and more number of times then those series will be put front, and which least will be put back, something like so. All things like these whatever the programming concepts, what I'm trying to say is like all generic. So in real world we usually do it actually, but only thing is what I'm trying to say is actually real world we do it, but we can do for 10 series, maybe 100 series, maybe 200 series, but like it is 1000 2000 10,000 something, then programmatically we should be able to write those kind of program can solve any kind of problems. Like so only thing, if you know how to solve that problem, find it algorithm and you can write it. So programs are very effective, and if the number is very big. Manually we can do like 10 series organizing very easy, because all these calculation is not necessary. But usually like so this is how the see in the see where it will be there. maybe in the Almara it may not be useful, but it may be useful in a Sari Angdi, so where so maybe they have 1 lakh kind of series, then difficult to which one to put fund, which one to put, because I cannot randomly, if you put actually, then there is waste, no, so I'm not utilizing the space effectively. So all everywhere, like, so these algorithms, what I'm trying to say is actually software is implemented in all domains, no, so something, and then there you will be using all these searching, sorting, all these algorithms actually, like I said, no? So you should, that is how I said actually, like, apart from the data science, even though our course is data science and AI, but you should be fundamentally, you should be very strong in that. So any questions here? So how should we go about, like, if you wanted to say that, like, if, okay, so many things, like, so what you do is actually, like, you list out the what all the concepts we should be learning. I said, like, I listed some concepts, and create a form of 4 to 5 people, and divide the problem into like 4 5 people, and then do all those things, like create, like, first find out what is the input, what is the output. Like, for example, any problem statement, there will be always try to spend some time on what is the input and what is the output. Like, for example, if I have to show you this problem, whenever the problem statement, you always start brainstorming about what is the input, what is the output. See here, this is a problem statement. So max sum continuous of a subarray. So you will give some kind of what is the input format and what is the output format, what is the constraint, and some examples, right? Because this is how you should start. When you explore more and try to understand more, then only you start building logics around. So how should I in last classes, output to start building a logic. Like, so see, I explained about Pascal triangle, no? So when I got this output, then I start building logic out around that actually. So this is how, like, so you should be starting finding out, like, input output, and then some kind of a core logic algorithm, and then what kind of data structures, like, in this case I told, no, so it can be array or it can be structure, and you think about, like, what is the data structures you'll be using, and then try to write that actually simple logic. If you are not able to get it actually, then find out where is there is sample code is available, and try to understand using visualization. And even if after understanding that, you should start writing your own logic and see that, like, whether it works or not, or like you can simplify the way I said, no, you can simplify something like this and then try to do, and then start building up that logic. So something like that you do. And when you are comfortable with that problem, like, you able to write an algorithm for that problem, then you try to explain that with the friends. So like you start, like, so I assume that, like, 10 programs are there, 5 people are there, two programs you split into. So you focus more on those 2 problems with all these permutation combinations and all those things. When you feel that, like, I got a grip on that, you explain that into all those 5 people, other 4 people. So other people will explain whatever they have learned actually. That is how what you will be overall, like, in 4 or 5 people, like, you learn the 10 problems. So 10 problems. And if you want to gain mileage out of it, actually, you can record that. Like, see, instead of, like, saying, putting a lot of information on the Facebook, like, I got this sari, that sari, this pic, that pic, instead of, you do this session explaining each other and make a video record of that, and then you put it actually. And that adds your profile actually. Like, people, you start sharing in Facebook, sharing in LinkedIn, or like something like that. So we brainstorm, and this is how we did. It's like what they thought, they think about it, like, this person is putting a lot of effort understanding that, and also you are selling it actually. If assume that, like, one person doesn't, all these recruiter forget about, like, maybe ignore the first one session actually, maybe second, maybe another problem statement, another case study, another mini project. If start building these videos and explanation and keep on putting, then they think, oh, these people are, like, serious, and maybe at least invite them for an interview. So this is how you can, like, instead of just posting pick about this, that, this in Facebook and something, like, so this also creates, like, so you are marketing about yourself. First is actually you are not doing anything extra, you are doing for, like, learning each other. Then you post it actually, and that is record will be remaining for a long time. You can refresh further also. So one is, like, your own use, and also you can market that actually. So you leverage whatever you are trying to do is multi-ways. And this concept is not, like, something like new or like something. This is something like, if you know the divide and conquer concepts, it is what I'm trying to say is actually divide and conquer only. So how exactly divide and conquer works? See, for example, if this is a number like 2, 3, 4, 8, 9, 10, 10, 12, or like something like 6, something like this. Divide and conquer, what will do? How many are there here? 4, and here 5. So divide and conquer, this is 4, correct? This is 4. So first divide and conquer, it will divide 4. Then it will divide into this. So it will divide something like, then it will do reordering here. So it will reorder here. It will do reorder here. This is 5. So it will, this is 5. So then what it will do? So this is fine. Then it will start merging that. Merging means like, so 2 with 3 will come, 4 will come, then 8 will come. So here how it will be, 8, 9, 10, it is same. So 8, 9, 10 and the 12. So then again it will start merging. So it is same. So 2, 3, 4 and the, so divide and conquer means like what I want trying to do, this bigger problem statement.
Unmute yourself. Yeah, now it is audible.
Yeah, fine, fine. So what you are trying to do is actually the same as the divide and conquer. So these are 10 problems. No, assume that there are 10 problems and I have 4 people. So I divide into 2, 2, 2, 2. So yeah, this is person A, this is person B, this is person C, this is person D. So he will explain, then he will explain to all these people. So it's like when you do divide and conquer is actually like a faster way of sorting something, no, efficient. Same thing, like, so the problem, whatever the problems, like, so problems, maybe 100 problems you are doing, 4 people, 20, 20, 20 problems. Weekly you divide actually every week 4, 4, 4, 4, something like. So then you teach each other, and then that is how you should start building. So if you are trying to build alone, that is also fine. But if you follow the, like, you build a group and start teaching it, actually you will be moving much more faster than in trying to alone. And even the same thing, like, so you can try this, all these subjects, whatever you're trying to do, you divide into subject, one subject, one person, or one subject, take one subject and then divide all concepts across the 4 or 5 people and teach each other. And all this you record it and then you market it. Actually, so that what happens, actually you are self marketing it. Actually, like, maybe you are learning, you are teaching each other, and you are marketing it. Actually, this is also shows actually you are group, you are a team player, you are a like teacher, a mentor, something like it. Shows your capability. Apart from the concepts, you can also showcase your capability. And one or other, maybe they ignore first time, maybe ignore the second time, maybe first case study they ignored, second case study they ignored, 20 case study if you do, oh, this person has done 20 case study, okay, maybe I will call for an interview. This is how you should start building. So start marketing about yourself, building your career profile, and self. So when you do all those things, no, even though assume that like they are not calling you, even though if you give we call company for intro for an interview or something like that. So what if you show that like I have written these many codes and these many videos explaining this, so then he will be impressed. No, so how many lines of code you have written, how many videos, so he will be impressed with that. So don't see, one is the learning, another one is you are not wasting anything. So all you start recording. So if you say that like, some records are not good, you forget it. Actually, wherever the concepts are good, whichever the things you explain well, you make the video and upload it. Actually, and you are marketing about yourself. One is learning and again teaching, and another marketing about yourself. Like, so you leverage the things in multiple ways. Don't leverage like just do one work activity for one thing. So you'll start leveraging that habit is, and also start dividing the things. Actually, like, so don't think about the bigger things, like even the bigger problem statement I said you how to divide into smaller piece. And then same thing, like divide and collaborate, work. And this, if you try to do that now, maybe initially it may look like very difficult, but over a period of time, if you start doing, maybe 3 months down, 6 months down line, will become very expert. Actually, and by the time like you have created so many videos and your communication skill is improved, presentation skill is improved, and teamwork, so then profile has built very solid field. Actually, so by the time when you complete all these case studies and many projects and something, so much more easier for get a job and sell about yourself. And also like somebody who has not done this and that somebody has done that, actually they were confident this person knows. Actually, so he knows about teamwork, he knows about present. So they will be more confident on you than hiring somebody who has not done anything. He maybe explained it, but like still they may have some kind of a doubt about whether to hire this person or not. they can see visually. No, correct. So this how you can differentiate, and this is how you can. They will be like like you will be getting multiple offers like how to build yourself actually, even though if you're not from the top institute or something. This because nobody bothers about like if you are able to explain properly, if you are able to and you know the concepts, and also all these records will be useful whenever you are trying to attend interviews and you can refresh it actually. So that's it actually. So any questions? How to like this is all about writing a like algorithms and preparing for the interviews. Okay. You want to take some 5-10 minutes break? 5 minutes break?
Yeah, okay.
Fine. We'll take on 5 minutes break. Then we will join.
You keep like that only.
5:20, 5:30 will join.
You will be keeping joining only. So we'll come back once.
So shall we start?
Yes.
So we discussed about some Pascal triangle and how to we break into small concept like break into basic concepts and then build on that, and then we also looked into like up in real world actually how it is on, and then we also discussed about how we study actually, how we study the study methods actually, how we study that we discussed actually. Now we will go a little bit like about the programming. So all we did so far is actually like in the programming key concept is sequence, selection, repetition that we understood. Apart from this also like there are something we should be doing. No? So whenever there is a condition, what kind of conditions, like we should also know something like operations, like what kind of operation is done. So something like arithmetic operations, logical operations, and bitwise operations, and some other concepts like string, number systems, binary, hexa, decimal, and these are the other essential things we should be knowing into. So uh, about the operations, if you wanted to see, there is something called arithmetic operators and something called a logical operators. There is a bitwise operators. Like I will explain actually, relational operators, assignment operators, and miscellaneous operators. So if you look, this is generic one. And if you look the Python, in Python, like we have arithmetic operators, relational operators, assignment, something, member operators, membership operators, identity, bitwise. So what is this operators means? Like, so whenever we say operators, so when you say the name, if you divide into that operators, like, so when you say operators, and there is something, it operates on elements. Like, so operator is operates on two elements. Like, so something like it may be two element, it may be one element, it may be any number. This is element A and this is element B. So there will be some kind of operators. Like, so this is where the operators will be there. Like operators will be there. What kind of operators? Like it may be two. This is called, if two elements, then binary operators. Like so one element, it operates on one element. Unary operators, trinary operators. Like, so there is a classification of operators. Other way of classification: unary operators, binary operators, and trinary. Binary, and there is a trinary. So this is based on how many elements it necessary to operate on. So what is the example? Arithmetic operators, there is something like a plus addition. So A plus B, there is an addition of that actually. So something that like there is a arithmetic operators are there, like plus, minus, multiplication. There is something like a relational than or greater than or. Those are those kind of operators are called relational operators. Like, so relation is like I'm trying to, relational name itself is relational relation, saying that like a relation between. So relation between two things. No, so if it is a relation between two things, then binary operators, this relation operators. So there is one element A and there is element B, whatever it may be. It may be like 10 or 12 something like. So what is kind of relationship? Are they equal, or one element is greater or another element is greater, or less than or equal? So what kind of relationship they have? So what kind of relations? So that is, well, yes, then yes or no. So the relational operators most of the times output will be yes or no kind of things, like so true or false. So is that relation is true or false? So whether they are equal or one is more or another less, like greater than x. So the relation operators is just checking the relationship between these two. So the name itself says no. There are so many kind of relationships like equal or than, greater, less, something like that. Assignment operators is something like I'm assigning it actually. Assigning is like, so I'm assigning some task to some person, correct? It's like a person A, I'm trying to assign some task. It's like I'm allocating. So I'm allocating some numbers. Like, so for example, P, I'm allocating number 10. It's like I'm assigning this value to this person, or some task to this, or some number to this actually, some identity to this, some value to that actually. So assignment operator is just like assigning some value to something. So this is something like any assignments, like, so for example, if I'm trying to even identity, so whenever you go into college, they will give an identity card. So that is all assignments, like, so this person or something like a Ram will have an identity card. That is assignments, no? So you will be assigning that identity card of that. Okay. So everywhere, like in the real world, there will be assignment with, like, some person assigns some activity, so assignment is actually like allocating some value or like some objective to it actually. So assignment operators are all that kind of things. And there is something like a logical operators. Logical operators means like, so you are trying to do some kind of see, for example, if I have to say, if A, you maybe heard about logical circuits or something that in electronics, but like I'll just say there is something like a logic called, there is a AND logic, and there is something called a OR logic, and there is something like NOR. So many other logics are the XOR and something like different logic are there. Like, so what is this logic means actually? For example, if A or B, so something like A or B, so whom to select? Like, so if, for example, if you are trying to find out a IPL match and you are trying to find out a opening combination, so whether I had to select Rahul with Rohit, or Rahul with something like a Dhawan, or Dhawan with another person, something XYZ like Kohli. So what is that actually? R is actually selecting. So selecting among some people. So selecting X and Y. But and operator is something that like, okay. So but openers will be two, no? So for opener number one, there is a first opener one and after two. Okay. No, so means like in this case I should be having two. So what is those two actually? Like, so means like, so I need to be collecting two. So or operation selection between these two, and operation is actually combining that. So how exactly this and works actually? So and works is something that like, so something that like this A, and there is something like a B, and I'm trying to do and. So what I'm trying to do and, so this person is something that like, okay, this person is expert. So something like this person is expert, and this person also is expert. So means like this is something like a true. So true, assume that like this person is true or expert something. So if this both, if I become like, so A and B. So when I say that both A and B, whether it is true or false, like I'm trying to find out is the best combination or not. For example, same example if you take. So if Rohit is like 100, his average is 100, and something like another Rahul is 100. So if I add these two, means like these two combinations, like if I add, like, so this is 100 means like true, like, so one or something like, so this two are true. So if both are true, then only that combination is true. So something like that, like, so and logic is something that like this is A and this is B and this is result. So if both this is true, this guy will also be true, and this is false, any one false. If this person is true, any one false, the result is false. So only one condition this will be true is both are true. So that and logic is something like that actually. If you added it, and means like both should be correct. So or is means like any one true, then it will be true. So these kind of like conditions will come. Like, so for example, if you are trying to find out whether rain comes or not, like for example, if rain comes or not, if the cloud is there, if the cloud is there, then or humidity. So assume that like humidity and cloud you are trying to take, humidity and cloud. So if rain has to come, it has to have both. So the cloud has to be there and humidity also be there. Then only rain comes. This is a condition. Then I'm looking for and operations. Like cloud has to be there, then humidity has to be there, then only. Or any one is there, like even cloud is there or humidity is there, any one is there, still rain will come. Then I'm looking for a or kind of operations. So any one condition is met, like either cloud is there, then the rain will come, either humidity is also there, then rain will come. If the weather prediction model is something like that, actually, I'm trying to predict a weather prediction model. So if there is a cloud or humidity, then the rain will come. Then this is one kind of model. Then I will be using or both has to be there. Then only we can say that like rain will come. Then and logic has to be there. So depending on where you are trying to play. So whether two is necessary or one is necessary or something like, based on that, like you will be finding, you will be writing that. Or so these are all part of a conditions. No, so how we will be writing? If for condition true, then I will write something like print. I will say rain will come. So this rain will come, or else rain won't come. So something how. So what is that condition? So something like I will write. No, if this condition is met, then I will say rain will come. Else I will say this is a true portion. This is else portion. So what I'll say, then no rain. So now what is that condition? So condition can be like two elements. There is element A and the element B. No, this is cloud and the element B. Whether there one has to be there, two has to be there, like depending on like and logic or logic. If this is true, means like if this has to be true, means like if and is there, both has to be true. Then only it will come here. If it is anyone is false, then it will come here. So that like, so whenever you're writing a selection kind of things or like any other any expression statements, so you should be thinking whether I should be using a logical statements, whether I will be using operation statement. So you should be knowing that, like, so but to know that, like, you should be knowing it, like what is meant by logical operators, what is meant by arithmetic operators. And so assignment operators I explained it bit, relationship. So I will explain in detail when I'm trying to tell in Python, but with the code. But right now I'm just giving, actually, like when you want to write a program or like program concepts, what all the key elements you should be knowing it. So logical operators I explained. Another something called membership operators, like so membership operators are like identity operators and bitwise operators. Just I will give brief kind of things. Membership operators is something that, like, whenever you are saying some membership, no, so in day-to-day word we use membership, no, whether this person is member or not. So whether he has purchased a membership or not. So what is that meant membership actually? So when I say this person has purchased membership, means like he has part of our team, correct? He is part of our team. So this is my group. This is something that, like, this is, I'm creating a society. I'm creating a society of elderly or something. I'm creating a society of North Karnataka. I'm so creating a society of Indians, whatever it may be. So whether if I say that person is got a membership for this society or not, means like whether this person is part of this group or not. So membership thing is actually what is the result will come. So if that person is part of that member, this group, then it will say true. If that person is not part of that group, then it will say false. So membership operators are something like that only. So there will be something like, what is this actually? This is something like a list. So there will be some kind of a list. There will be some kind of a list or a group or something. So what I'm trying to show, whether this person is in that list or not in that list. So in that means like he is part of it. Not in that means like, if not in that, like, say for example, if that person is in here, the person something that this person is inside here, like, so something that like this person called A. So here A, B, C, D, all these are like A, B, C, D is there. A, B, C, D is there. So all these are there. Now if I say in, if A is in this list is called something like L. If it is there L, if A is in L, so this will result true, correct? This will result true because A is there in this list. So this is a list actually. This is called as a list. So if A is in that list, then this will be true. If I'm trying to find out other way around, like if I'm trying to find out not in, so no, not in, what happens actually, A is not in this, but A is there here. So this is false because he is there in that. So A not in will give false because he is there part of that actually. That you should be remembering. Not in means like he's looking for whether he doesn't exist or not. If it doesn't exist in that list or not. So if doesn't exist but he exists, then it is false. If doesn't exist, he doesn't exist in that list, then it's true. It's like I'm asking whether this person is not part of it. He is not part of it, then that is true. Because yes, he is not part of it. If I'm asking he is not part of it, but he's part of it. No, he's part of it. So it is false. So that is how you should be looking. All this very, and if you look the statements also very simple actually. Usually like in, not in. In means like whether in that list or not. So that is how you should don't add those things actually. Membership operates and name itself is says that name that's called membership. So you already know the membership. No, identity operators actually like I'm trying to find out the identity of something. So what is that identity? So for example, whenever you say that like identity of something like okay, this A is equal to something that like B, both are same or not, or if you say that like both are from same college or not, so that's some kind of, or this like so something like see something like IITs are not NIITs if you're saying whatever it may be IT, whether he is equal, so something like identity is actually whether both are equal or not equal, so they are same or not same, so they are belongs to same kind of category or not. So identity is or is not. So both are same or not same. So identity is actually I'm trying to find out the identity of that. Both they are same or not same. So something like so. What this is the difference between here actually here only two entity. Here I'm trying to whether that person exists in that or not. But here I'm saying that both are same or not same. So that can be done using assignment like so this relationship thing. No, both are same or not. So identity is something that like or like another is like is it like so where they will be using this one and this one is actually here is this is a car or is this something like it can be more generic way. I will explain that in whenever I'm explaining Python. But identity is something that like is both are same. Okay, for example, this is instead of A, so I'm trying to say that like 10. This 10 is int or not. So this is also this is of type int. Okay, I'm both are same. So the identity is something like that way it is used actually. Both are same or not. But like the name itself is that like I'm checking the identity. Identity means like same or not same. So that you should be remembering. And this is all necessary. Like so when you're writing a condition, like what you are trying to do? We are trying to check actually both characters are same or not. Like so the strings, whatever the like so like whether this person college is a premier college or not, or like something like that. So identity, like so that way you should do it. And another one is a bitwise operators. What is a bitwise operators? So so if you look all these operators, like so I said operators means like this is addition, subtraction, multiplication, whatever I'm trying to say. No? So this is A, when I say A plus B. So what is this A and B? So this, if you wanted to know more like what is this A and B, this is assume that like even if it is an int. So but is it int means like integer, but is it integer of how many bits? So I think I explained last time that about some kind of a structure, no? So some kind of computer system and bit how many bit of operations it will do. 32-bit operators, 32-bit processor are like 64-bit processor, something like that. So when you say when you wanted to know about the bitwise operators, you should be knowing about like what is that algorithm. So if see here, if you look this one, this diagram, what is that actually? This is ALU of 32-bit. It means like what is saying actually, even if it is a bus is a 64-bit bus actually, but I am having two ALUs of 32 bits. Like it can only compute to 32 bit. So 32-bit data. Means like what we should be knowing here is actually like, for example, any number. So if it is, see, for example, this number, this is a decimal number, I should be converting into something like a binary. So if I convert into binary, so this is how it will come onto. So sorry, this 8 will come something like this actually. So this will take 4 bits. So then if I'm trying to add bitwise, it's like I'm adding bit by bit. Like, so for example, the same thing, but I'm not adding in decimal wise. Like, so 8 by 7, if 8 plus 7, if I'm trying to add here, it will come 15. So if I'm trying to bitwise actually, like I'm trying to do something like this actually. So I'm trying to do a bitwise actually. So all these I'm trying to do is bitwise. So bitwise adding. So this is how it will happen. But what is the difference in bitwise that actually I'm trying to do? It's like if I'm trying to do or, so or and, so if I'm trying to say and or, like, so and something that, like, if I'm trying to do this to and, so this is true because any number zero and above is considered as a true, then this is true, and this 7 also considered as a true. So both are true. And if logical operator, if I used actually, it will give something like another true. It value can be anything above 0. It may be, say, it may not be 15, so it can be anything. It can be it can be 1, it can be 10, any random number, so depending on that. But like, that is a true, so finally it is true. This is the uh, on the data sometime. But the same thing if I'm trying to do bitwise, so what it happens actually, this is something I'm trying to do. So this bitwise, if I'm trying to do, so actually, like, this is true in decimal point of view, this is true. And if I and it actually, if I'm trying to and logically, if I'm doing like logical and, so result is true. So both true is true. If I do same thing in a bitwise and if I do, so that is another symbol, something that, like, I'm using this symbol. So what is there? This two. So this two will be, so one is zero, one is, like, this is false, this is true. So this is false. This is false, this is true. This is false. This is false, this is true. This is false. So this is false, this is true. This is false. So what is the result? This is false. So even though the same value, if I do and logical operator, and if I use bitwise, the result is different. Here our result is true, here result is zero. So this, but sometimes I should be doing the bitwise, sometimes I should be doing the but that logic you should be knowing, that, like, when you have to do bitwise, when you have to do this one, so that you should be knowing. But like the program will give, like, any programming language will give all those ways of doing. So if you want to do bitwise, then you have to have operators for that. If you want to do yeah, whole numbers, then there is operators for that. If you want to do additions, there is arithmetic, there is operators for that. If you are doing relationship comparison, something, that there is operators for that. If you are doing assignments kind of thing, there is operators for that. If you are trying to find out a membership kind of thing, there is operators. It's like the objective is the programming language. Actually, they will give all those operators so that, like, you will be a rich kind of operators, and then depending on what conditions, what you are trying to make, you will be using appropriate operators. So you will be using appropriate kind of operators. So but if you look at actually, like, systematically, if you look actually, like, all those operators are possible, or like a computer can compute all those operators? No. So this is the ARM basic question of ARM commands. So if you look at actually, like, they may not be having all those operators. Like, so they may be having something like a logical and is there, subtract is there, add is there, some kind of a bitwise move and clear is there. Well, only these kind of basic commands are there. But when, if you see that, like, how many different commands, like different operators are there. So you may be having
You can
multiple.
clarify the doubt now.
Hello. Yeah.
Yeah, one person, Santosh, is raising the hand. You can clarify his
uh,
doubt.
what is the question? Hello. Hello. Santosh, any question?
Long back itself, he is raised, but he is not asked anything.
Okay, okay. I thought the fine.
Yeah.
Hello, sir.
Yeah. Tell me.
Yeah, sir. This is arithmetic operator and that is bitwise operator. Sir, both are same, na, sir?
No, arithmetic and bitwise. Okay,
Yeah.
let me. Let me
Sir,
tell.
if that is
What is the
arithmetic operator, both are, that is, conditions are false, then the output is true.
1 minute? Arithmetic operators. These are the arithmetic operators, like addition, subtraction, multiplication, division, modular. These are operators. So bitwise. So if I have to show you bitwise operators, there is no. Let me see. Bitwise operators are like something like a bitwise. Let me, okay. So So these are the bitwise operators: bitwise AND, bitwise OR, bitwise XOR, bitwise one complements, bitwise left shift, bitwise right shift. So usually, see, you got it, no? Arithmetic operators is this arithmetic operators. These are the arithmetic operators. So these are the arithmetic: addition, subtraction, multiplication, floor division. These are arithmetic operators. So why I explain that is actually, I explain in two ways. Like when I explain that, like when you are trying to add, so there is no difference between if you add whole number or something that like, so bitwise also, like, so if you add two number, like finally, like, so any number will be converted into binary. Any number will be converted into binary, then you will be adding it actually, because that is how the ALU logics are there. So there is no like addition, there is no something like a bitwise addition or like something like so. But what I was explaining the difference between is like bitwise OR and bitwise AND is, so when you say when you try to find out like AND, like, so this is 8, this 8 and 7. If you do so logically, if you do, then it will be true, and true means like value can be anything 1 to any number, random number, 1 to 10 or 15, any number. This is the logical AND. But bitwise, if you are trying to do that, the result will different. So that is what I was trying to say. So is it questions you so your question is addressed, or like you still have confusion? Hello. Hello. So you still have question?
Is that clarified?
No, sir.
So I will explain actually. Bitwise, if you see here, no, bitwise AND is there, bitwise OR is there, bitwise XOR is there, bitwise left shift and right shift. Okay, bitwise AND I explain. I will explain one by one. That is fine. So assume that like, so this is one number, and I'm trying to do something like this actually. So this is another number. So this is what is this number? This number is 8 in decimal wise. This number is 15. Correct. So this is a 15. So this is a binary number. These are all binary numbers, and this is the decimal value. So now, if I do bitwise AND, something like this is the symbol. So what will be value? So this will become 0. This will become 0. This will become 0, and this will become 1. So what is the result? So result is something that like 8. So if I do bitwise AND, so I get a result 8. But if I do logical AND, so what happens actually? This is true and this is true. Both are true. Anything above 0 is true. Anything above is 0. This is true. This is true. True by true, it will still true. So what is the value here? Value may be anything above 0. It may be 1, it may be 2, it may be 3 randomly, depending on it. But here also true, I got fine, but value may be different. But sometimes bitwise operate and logical AND may match, sometimes may not match. Instead of that, if this value is 0 here, so value will be different. So that you should be able to remember. So that is what bitwise and bitwise OR, if I'm trying to do, like okay, forget about OR. No, any one is true, then it is a true. So for example, both here true, then result will be true. If I'm trying to do OR here, the same value OR I'm trying to do, what is the value will be? The value will be 1 here, 1 here, 1 here, and 1 here.
0.
So no, 1 or any one will be 1, value will be 1.
Yes.
So then it will be 15. So now 15 means true. So this is also true. This is also true. Fine. Or both are same. But I'm not able to say this true means like 15. So it may be something 1, it may be 6, it may be 7, it may be anything. So that when you do logical AND, you can't predict. Like only thing you can take it either is true or false. But you cannot judge anything about the value of that. But if you are wanted to do something like a bitwise OR or bitwise, then you will be doing. So this is how the bitwise OR. So then what is the XOR? So XOR, what is the XOR means? XOR means like if both are same, then 0. If one is different, so XOR is a different, something is different, then value is equal to 1. So XOR like something like this. XOR, please mute it actually. So what is the XOR? If any one is one, then there is a difference between this value, then it will be one. If both are same, then it will be 0. So something, this is called XOR logic. So what is that actually? Bitwise. So bitwise XOR is actually like I'm doing. So this is the logic. So now what is the difference between bitwise XOR and AND logic? So for example, if I'm trying to do like any number, like there is no, so if this number is 8 and there is number is something like fifth, like something like a 12 if you take. So there is no logical OR actually, the XOR, there is only bitwise XOR is there. So now if you look actually, what is this value? This value is something like this. And 12 is 1, 1, 0, 0, correct? Okay, so 12 is 1, 1, 0, 0. So this is 12. So now if I do XOR, bitwise XOR, what is the value I'm getting? So 0, 0 is same, so it will be 0. 0, 0 is same, it will be 0. 0, 1 is the difference, so it will be 1. 1, 1 same, it will be 0. So what is the value I'm getting? I'm getting value 4. So this is bitwise XOR. So the bitwise XOR is actually like, so when we will be using bitwise XOR, like instead of learning this one, when we will be looking for a bitwise XOR, bitwise XOR will be looking for finding out the difference between those bits. So for example, if I send her something, so if I got one element like A and B, and I wanted to see that like in terms of converted into binary, I want to see that like is how many bits, like same bits are set here also, same bits are set here also. So for example, if so bit number like, so something like bit number 0, bit number 1, 2, 3, so this is how the binary will be there, no? So this bit value is 0 or 1, 2, something like this is 1, 0, 1, 0, 1, something like that. This is 3, this is 4th bit, this is 5th bit, 6, something like 6th, 7th, and 8th bit. Now correct? So 0 to 7. So something like here. So if both all bits, same bits are set or not, means like both are same or not, or like there is something like if both are same, what happens actually? So XOR value will give 0. If A and B is both are same, so XOR value will give 0, because all these bits, wherever there is the same thing, so it will give 0. If there is a difference, it will give that value. It's like if I am trying to check actually whether A and B are same or not. So if you do bitwise XOR, if the result is 0, then both are same. If result is non-zero, then both are not same. And apart from that, like it also shows actually bitwise OR shows actually which location that element is, the bit is not same. So for example, if the value is something like 800, something like I got value 808, means like the 4, 0, 1, 2, 3, third bit is not same. There is a difference between third bits of A and B. So if I got value, some two values, something like 12, then 2 bits are not same. So third bit and fourth bit are not same. So apart from saying same or not same, it also gives something that like which location they are not same. So if you wanted to see that, like if you are trying to do something like an embedded system or something, and you wanted to see that like this is a register value I have fit initially, this is a register value I have set actually, and after some operations I'm trying to check the register value, and then I'm trying to check actually is something change happened in that register value or not, is the same or something got changed. So one is actually, it will give whether it is same, yes, it is same or not same. Even if it is not same, it will say that like which bits. So it is 8-bit kind of register. So if it is 8-bit register, which bit is something not same, like something third and fourth bits are not same. Fourth and third bit are not same. So okay, third and what is the third bit represents what is the fourth? So what happened actually, like something stays change. So initial state was something here, then the state change, something like, so these kind of like, so you wanted to check those kind of write some those kind of logic, you will be using bitwise XOR. So see, apart from like understanding what is a bitwise uh, uh, operations, you also know that like when it will be used, when bitwise is useful, when logical is useful, when you have to use those things you should be knowing, and what is the right shift and left shift. So for example, right shift and left shift is actually like, see something like this is a number. So this number, if I'm trying to do this is a this direction, whatever the direction, this direction shows something like, so this direction is right, correct? So this is your right side. So this is your left side, correct? So this wherever this arrow mark indicating, this is what. So if you say this with number 1, so if you say this number 1, so it's like you will be shifting 1 times. So what will happen actually? So this one will move out actually, and this will come here, and this will come here, and this will come here, and here one new 0 will come. So means like it will become 0 1 0 0. So means like what happens, earlier it was 1 0 0 1. So means like this number was 9. So what I'm trying to do is number is 4. So what I have done, so earlier its number was 9. So 1 0 0 1 is 9, correct? 1 0 0 1 is 9. So when I right shift actually, it become 4. What is that means actually? So if you look at the logically, this one actually, the 9 and 4. So if you divide, so something like there is there a floor divide is there. So if you divide by 9 divided by 2, if you do floor divide, means like floor division means like it is gives a integer result. So for example, 9 by 2 will give not, it won't give 4.5. So it will, floor is something like here, ceiling is something like here. So what it means like whatever is the lowest, like so 4.5 is here. So it will say that like it will remove that and the result is 4. So if you divide by floor divide like 2, like so this was here, no? So if you look, this is a floor division. So 2 slash, correct? In Python, I'm trying to show. So what happens actually, 9 by 2 means like even 4.5, floor means like I am taking lower side. So 4.5 is higher, no? So lower of that is 4, integer value of that. So ceiling, if I have to take, then it will be 5. So it is a 4 division. So if I do floor division, then it will go 4. So if I do right shift 1, so then what I'm getting is something like 4 division. Correct. So if you look that way, so the same thing what you are trying to give. It's like you should think about that. Like, so what it does. So just doing right shift and right. Okay. If I do other way around, what will happen? So something that like 1 0 0 1. If I'm doing like this shift 1. So how it will happen? So this will come here, and this will come here, and this will come here, and this will come here. So now what will the result, and what will be the new value here? New value always will be something like a 0. Assume that. So now what happens? 0 will come here, 1 will come here, 0 is come here, 0 is here, 1 is here. So it's like this is 4, 1 2 3 4 5. So sorry, this 4, no? So here, this is new one. 1 2 3. The value is, this is a 9. So what happens like the 5 bits it becomes, no? So what is the value here actually? This number is 16. This is 16. So 16, this is 2, correct? 16 plus 2 is 18. So what is that happen? What is that happening? Is actually like, so if I shift 1, so what is happening? 9 becoming 18. What is the relationship? It is multiplying. So if you shift left actually, then I'm multiplying. So how you are multiplying? All this is shift by 1. So what is that relationship actually? Whatever the value. So this is 2 to the power of that shift number. Like, so this is number n. So this is number n. So that into the number. So this is how you will be finding out. Like, so what is this number is 9. So this is how it will multiply. So if I shift by 1, so this is 1 means like 2 to the power of 1 is 2. So I'm multiplying by 2. So if I shifting by 2, then it will become 2. 2 to the power is multiply by 4. So it's like you should be able to think. It's like you do manual kind of activity and then find the relationship, and then so you should start understanding that way. So if you do right shift, like just right shift, but what it is trying to do? Oh, then is there any other way I can do the same thing or not? That is how you should start learning, not by hitting it actually. So this is a bitwise left shift and right shift. So if you look at actually bitwise right shift and left shift. So this direction is left. So it's like, so this direction, correct? So this is a point. From this direction is your left side. So this direction is right. So this is a point. Then you are doing right. So bitwise and this is bitwise and. This one OR, this is bitwise OR, and this is bitwise XOR. And what is this one complement? What is a first of all, what is a complement? First, you should be knowing what is a complement. Complement means like I'm giving compliment because somebody saying that like this is my complement. Complement means like I have some characteristics, that person has other characteristics. Where I am lacking, that person is having that actually. That's I'm looking for a complementary skills. Complementary like X and Y people are complementary skills. Like if you are to start a startup, you should be looking at complementary skills. Means like I am very good in technical. I should be I'm not good in marketing. Then I will be hiring a person with very good in marketing. So another so that is called complementary kind of skills. So generally terms in English we'll use look for a complementary skill founders. So that like I'm good in technical, another person in marketing, another person is operation, another person in finance. So means like all are complementary kind of skills because that is all necessary for running a company. So one person finance guy, one operation guy, one something like. So same thing in complementary, something like. So complement means like this is a bitwise number. So what is a complement of 1 is 0. What is the complement of 0 is 1. So what is if I say complement, if I take complement means like 0 becomes 1, this 1 and 1 becomes 0. This is a complement. So this is what is the complement. So this is 1's complement. If you want to take a 2's complement, so this is 1 complement. If you want to 2 complement, you have to add 1 to this. So that's called 2's complement. So you should be knowing these are all basic mathematics, basic fundamental actually. And what the programming language gives actually for this, all these basic things, what you have learned, addition, subtraction, multiplication, all those things, it will give some kind of a representative. So representative is like what keyword was like what symbol you have to use to build that logic actually, because finally whenever we say that like whenever whatever the logic I say, I'm trying to say add, like I explained in that last time. No, so where was that actually? Let me show that. When I explain this problem thing, no, so finally what I'm trying to do, I'm trying to multiply, I'm trying to divide, I'm trying to do difference, I'm trying to do so all those things, like there should be some kind of symbol or some kind of operators I should be using it, correct? So this is what actually, this is multiplication. No? So then you will be using arithmetic operators, like so multiplication. So to any all those operations, like small operations, what you have to, there should be some kind of a operators or symbols or statement or something like. They should be have. Then only I can write a program, correct? So then only I can write a program. So there will be something like, so if you look that, so there is arithmetic operators, there is a logical operators. I explained about relationship kind of, there is a bitwise operators, there is assignment kind of operators. No? So, and this is all simples, correct? Addition, subtraction, multiplication, arithmetic. So because you do day-to-day addition, will do day-to-day subtraction, will do multiplication, will do floor division. I explained. What is this exponential? Exponential is something that like, okay, there is something multiplication you are trying to do, correct? So the 3 into 3 is 9. So exponential, if I do another star, is actually it will become 3 by 3 to the power of 3. So it becomes a power symbols, like, so it is exponential. It's like to the power of something. So this is a different symbol because I have to use a different symbol to represent different. No, the multiplication is different and power is different. I should be using different symbols to that. So the symbols is depending on which programming language, there will be something like. So for this is for exponential, and this is for multiplication, depending on the programming language. So, and what is the division? The slash. Floor division, this division and this division, what is the difference? So if, for example, this I did know 9 by 2. 9 by 2, if I do floor division, this is normal division, then it will give 4.5. So, but if I do floor division, then it will give 4. So now you wanted to find out, like, okay, this is what is a term, but how should you think? Don't think that like, okay, normal division, floor division. You should think something like, oh, why? How should I leverage the floor division? So see, this is a floor division and this is the normal division. So this normal division give 4.5 and this floor division will give 4. So now how should I leverage this? Can I leverage something with the floor division? Okay, now you wanted to find out whether that number is divisible or not divisible. For example, if 9 is divisible by 2 or not, if you are trying to find out 9 is divisible by something. So if this number is divisible by this one actually, then the floor and this normal division gives same result. So for example, if say, so if I do 8 by 2 and 8, floor division, if I do 8 by normal division 2. So what I get is actually 4 here and 4 here. So if so something is not divisible, if not fully divisible, the floor value and the normal value is different. So that is what you have to check. If that number is divisible or not divisible, not using proper division method or something that like so. So if you find out that was divisible or not divisible, so using the same thing. So how should you do? I should not use this month. So different method. So how should I do? So one way is actually I see this is assume that like I'm calling this number as n. So n divided by, I'm saying that like divisible, I'm checking by m. So n floor divided by m and into multiply by m. If I give, if I get this both is equal to n, so something that like, so this n, whatever is n initial original one, and but that original n I am floor divided by m and multiply by this multiply by m, and if both are equal, then I'm thinking that this m divides n. Correct. So you check it actually. This is the logic you can create. So how we like, so 9 divided by 2 into 2 is equal to 9. That is what I'm checking. No, so 9 divided by 2 is a floor division. Sorry, this floor division. This will give 4 into 2. So this will give 8. But this is done. Both are not same. Correct. So something like now, if it is 8, then this will give 4 and this is 8. So this is how we can do. Okay. Now we also understood that if I do like this, actually this is a division. Correct. So without using any divisor operators, like how should I do? Now, if you wanted to do that number, like, so what is that number? If assume that like, if this is a number of like 2 to the power of something, like if m is 2 to the power of some number, like, so for example, m is of power 2 to the power of some number, like 2 to the power of 1 or 2 to the power of 4 or something that like. So now if you are trying to do so that m, so find out this is something like x. I have to find out something like x, which see 2 to the power of that x becomes 1. So something like 2 to the power of x is equal to m. So I found out this x value. So then what I will be doing? I will be doing that right shift those many bits x, and then what I will be doing again right shift. Sorry, this right shift, this left shift with that x. And if I do those many right shift, there must left shift, and then value is same, they're same. So this is the same thing. Like, so I'm doing one something like this. If I'm doing this one, so value is 1 0 0, and if I do again one something like this, value is 1 0 0 0. This becomes 8. Correct. But originally, if number is 8, it will become 8. Means like if both are same, no, here it is not same, so not divisible. But if this original value is 8, then result also will be 8, and both are same, then it will be divisible too. So it's like I've not used division, I have used something like this. So you should start thinking about like, so if you understand what exactly it does, you deep dive into that, like what exactly this does actually, right shift means like, right. So when you start understanding and comparing, and then you can build these logics. If you are just remember right shift is like this, right left is like this, like then you won't be it. So you should start thinking about these operators, what exactly they do, what exactly they will do. Is there anything I can infer from that actually? So if I do right shift or left shift, what exactly it does, and can I infer something from that? So can I use this logic instead of something else? So if I use this one, actually there is no need to for modulo. So there is another command is a modulus. No, modulus also gives that what is the modulus of that, like whether it is divisible. So for example, the same thing, like no 8 divided by 3 modulus. If I say modulus, then if it is completely divisible, it will give value result is 0. If it is not divisible, here it is not divisible, the value it will give is actually 2. The remainder it will give modulus, if you give it will give a remainder. So modulus operator. So sometimes I cannot be using that, like, so whether it is divisible or not divisible, if you want to check, you can do the same way. So here, like using modulus, if you want to check whether it is a divisible or not divisible, I will be doing modulus of that number. So something like n modulus m, and then if the remainder is not equal to 0, if not equal to 0, then it is not divisible. If it is equal to 0, then it is divisible. So you can use modulus, you can use floor division, you can use bitwise operators. So that is how you should be start. So thinking, okay, without this, how should I do? Without, so then when you start thinking in that direction, then you start building that logic. So it is not that. So that when I say that, like, we create a group, so you start thinking, oh, without this also can do this. So it's like, ask some questions, like ask a point, like, so understand that. Like, so you create a group and then brainstorm like that. Like when you start understanding that way, that you can start building the logic. So I'm trying to say that, like, just don't read actually what is the modulus means, what is the exponential is like. So okay, now you think about exponential. So how should I exponential? See, for example, if you look at actually any of these ALUs, like, so I told about like ALUs, finally that is what. So if you look at the ALUs, so what are the things you get is actually ALU is like arithmetic logical unit. No, that is what it will compute. So finally it will be, there is a multiplier is there is a adder is there is a divider is there. But when you see the programming language, they say actually there is addition is there, fine, it is there, equivalent. There is subtraction is there, it is equivalent is there. There is a multiplication is there. There is no subtraction actually here. Okay. Oh, but we have a subtraction. So how should I get a subtraction without having a subtraction ALU? Because finally ALU is what it will be execute. No, say when processor is processing, means like it is doing that operation. If there is no subtraction, but all the logic what is adder, then how should I get a subtraction from a adder? So that you are, somebody is like who is writing a compiler will come to know how they will convert into that way. But if it is not there, then how should we do? So if you look at actually addition, subtraction, and multiplication is there, but there is no something like an exponential is there. We'll think about like what is it exponential? Can we, okay, but in ALU there is no something like an exponential is not there. So what is that exponential? Even if the exponential is not there, so 2 to the power of 3. So what you are trying to do? So 2 to the power of 3, any number you are trying to multiply with those many times, correct? So like, so 2 to the power of 2 is what actually, hello? 1 minute. See, to the power of that. So to the power of that means like actually you are multiplying those many times. So 2 to the power of 3 means like you are multiplying those many times. So 3 times. So what is that actually? So okay, then any exponential, you are trying to do some kind of a loop, correct? For loop with that number. So you will be multiplying. So what is the number? Number is something like m. How many times? N times. So to the power of n. Means like you will be, this loop will be doing till n times. So you will be multiplying. So how is the equation? So m will become, so this is m into m. So one time it will be multiplied. So then what is the second time? So second time it will be multiplying double to that. No, so this is how we'll be doing 3 into 3 into 3 into 3. So much like, so the m in each first it will multiply m and m. The next m is actually it is this actually. In to this you are again multiplying with 3. So but here it should be only one times. No, so but I am modifying this again. So when it doesn't become that way. It has become 3 into 3 into, and this 9 into 9 it will become. So how should I preserve this multiplication, and how should I preserve the original value? That is what, like, so a lot of people, they suddenly they will do that something that, okay, log means like m is equal to m into m. So means like, but this m, whatever you are trying to multiply, this is original value. But finally, like this m is the resultant value. So resultant means like if first time you do 3 into 3, then you got 9. Next time you multiply by 3 means like this instead of this, it will be 9 into 3. So then next it will be what was 27 into 3. So this value keep changing, but this value is constant. And this result, whatever this and this should be same. So that you should be able to understand that. So means like you should be, so this is always constant. So then you should be writing a logic there. So those kind of small observations you should start thinking about. So then what happens actually without exponential, you are trying to do exponential using the multiplication. So then you can write, you are writing your own exponential kind of functions. So that is most like, so just using multiplication, then that is the logic. So you should start thinking in that direction. So multiple operators. Then what happens, like your logical thinking and programming skills will keep on increasing. So any questions so far? So we just covered all these operators, and you already know this is not is a logical operators. This is a modulus. This is like, so any questions here? Like we will end here. I think it is 6:30. So we'll just sum up these things like we discussed about the programming, like operator concepts. So any questions so far till this? You are able to recognize this, no? This is, what is this? What is this? What is this? And all those things. So another thing here, no, see, what is this actually? This is greater than, this is greater than, it's like this side should be greater than this side, correct? So just if you do this way, so whatever this, like this side is greater than this, that is what you are trying to check. This is the bigger direction, no? This is bigger gap here. So this is greater than. When I say equal, means like always equal won't be this side. So why that is that way? See, whenever we say something like n equal to something like n plus 1, then what you will do? So this is how you will do. So whatever this operator will come second, this operator will come first. So usually whenever, like instead of this one, if you want to shift, so how it will be done is actually, this is how it will be done. So n plus 1, this is how it will be done. So these are like, if it is greater than, so this is how it will be done. Always this equal is the right side. So that you should be remembering. Those silly things like you should not be doing. Always like whether it is a plus something like, where is a plus, this way. So this is, you should remember. All these symbols very pretty easy. This is a bitwise or like and this is a logical. These are all Python thing actually. These are Python symbols actually. So any questions? If there is no questions, like we can time it. Like any, are you comfortable or are you able to understand what I'm trying to say?
Yeah, we understood all the concept.
Fine.
What about other side? We have to check.
Fine. So
And already 6:25 is there.
so shall we end?
Some more people are.
So shall we end?
Yeah.
Okay.
If anybody have any questions, they can ask. Otherwise, we'll end the session.
Okay.
Yeah.
Okay. Good night. So we'll meet tomorrow at 4 o'clock.
Okay. Okay. Thank you.